Okay, so figure shows an early water power device used to raise a heavy load. The heavy load rests on the piston B. So you have the load is present here and the water is present here. And then there's a hydraulic press, which means you actually can move an object upwards or downwards by making use of the water being added. So you are applying the force here. Initially, a large beam of water in cylinder A pushes the piston A down. So if you put more mass here, you can expect that the piston will come downwards like this. And then this causes the left hand end of the beam to move down and the right hand end of the beam to move upwards. So this will now start moving upwards. And then lifting the heavy load, the weight of the water in cylinder A is 80 kilonewton. So this mass M into G is given as 80 kilonewtons. Calculate the mass of water in cylinder A. What is the mass of the water here? How do we do? What is the mass of water here?
It's the weight divided by 10.
Yeah, which should be 80 kilonewton divided by mass is equal to, so by G, okay, mg is equal to so much, so this should be equal to 8 kilonewton. Sorry, kilo kgs, or maybe I will write this as 8,000 because K stands for 1,000, 8,000 kgs. Okay. The density of water is 1,000 kg per meter cube. Calculate the volume of water in cylinder A. What is the volume of water in cylinder A? How do I find volume? Which formula?
Well, density is equal to mass by volume. So it's the density, sorry, the mass divided by density.
Mass divided by density, which should now be equal to 8,000 kg divided by density, which is 1,000, which should be equal to how much? 8 meter cube. 8 meter cube should be the volume of water in cylinder A. Okay.
Yeah.
Then piston A moves downwards by a distance of 4 meters. So this moves distance by a distance of 4 meters. Calculate the potential energy lost by the water. What is the loss of potential energy here? What is the loss of potential energy? How do you calculate the potential energy? What is the formula?
MGH.
MGH. Okay. So what is the loss of potential energy? Well, how much potential energy is the water has lost while moving down?
4 into mg.
M. What is value of M here? Yeah, 4 into mg. Okay. So I will write this as 8,000 multiplied by 10 multiplied by 4, which will be equal to 4 8s are 32, then 4 zeros. 1, 2, 3, 4. Put this. What's the unit?
Joules.
Joules over here. Okay, so you can also write this as 3.2 lakh joules. Can you say that?
Yeah.
Lakh joules. Okay, so this is what we can say. Okay, now whenever we talk about a loss of energy, there should be some difference here, right? Okay, mgh1 minus mgh2, okay, and so on. But I have written only mgh. Where is that other negative part? It's not been observed. You should now say, I don't know whether you get this or not. Okay, after water has been poured into it, the new position of the piston should have been like this over here, right? So therefore, now you should have calculated this energy. Let me call this as E2, and then you have calculated this energy, which is E1, and then your loss of energy should be E2 minus E1. But I didn't do all this. I just directly taken here. So what is the reason? Is my answer correct? Yeah. Yeah. Where am I missing this conceptually?
I'm not sure.
Okay. Now, when you say about this potential energy MGH, which energy is this? Which energy is this? Is it the energy E2 or is it E1?
E1.
E1? That means it had some energy, then it lost its energy while it came down. Then what is the energy E2 here? I have not calculated that.
Yeah.
Are you getting my question?
Yeah.
Right. Okay. So let me explain this. So initially what we do is in any physics problem, we have to put a reference level. The reference level here is that before I started, I didn't know anything about it. I just knew what is the mass, what is the acceleration due to gravity, and so on. I will assume that this is my reference level. This is my x-axis here. And anything that I measure upwards is positive, and everything that I measure downwards is negative. As a result of this, my E1, which is nothing but the object, even the water level is not moving anywhere, right? So it doesn't have any kinetic energy. It has only potential energy, which should be written as equal to mgh. And since I have taken this as my origin, this will now become equal to 0. Did you understand?
Yeah.
And this E2, what is E2? E2 is nothing but mg into, I've measured some value here. I said that the water levels as the piston has moved by a distance of 4 meters downwards, which should be -4 over here. So your answer here is not just 3.2 lakh per joules. I should have suggested that there's a negative sign here. Is this clear?
Yeah.
Okay. So if this is a 3-mark question, you have to do it like this. You should say the potential energy lost delta PE is equal to E1 minus E2. And then you should substitute these values. Okay. MGH minus 0 minus MGH. And you need to substitute here. Okay. H is nothing but the height. It has gone down. You substitute this, get the negative sign. And then finally you have to write the answer. In the answer, you have to mention that the negative sign implies energy is lost or energy is spent. Did you understand?
Yeah.
Okay, but if you just write delta P is equal to mgh, you will just get only 1 mark there. For calculation, 1 mark. For change in potential energy, 1 mark. And then what is the negative sign mentioned, that comes out to be 1 mark. And in between, in the final answer, okay, when you do not write the units over here, you will lose that mark also. This is not required. 3.2 lakhs joules is not required over here. You can just keep it like this also. 3,20,000 joules also fine. Or you just write it like this is fine. But you should mention what is this unit over here. Is this clear?
Yeah.
This will give you an additional bonus mark. Okay, which means that if it's a 3 mark, and anywhere if you have made a mistake also, if you have mentioned this, you will definitely get a mark there. Then the heavy load lifted by piston B gains 96 kilojoules of gravitational potential energy. Calculate the efficiency of the device. What is the efficiency? Efficiency eta.
Yeah.
Efficiency eta is equal to?
Well, it's the output by the input
Output by input. Into 100.
Into 100.
Okay. So tell me what is the answer? What is output?
96 kilojoules.
96,000 divided by input. 3,20,000.
Oh, yeah.
Okay, that's the change in potential energy. So therefore, cross these zeros. So can you tell me what is the answer for 96 by 320? Multiplied by 100. 32 3s are 96, right?
Yeah.
So this is 3 and this is 10. Multiply this, it is 30% here.
Yeah.
Okay, so the answer is 30%. Did you understand how to do problems like this?
Yeah.
Okay, next. A water tank has a rectangular base of dimensions 1.5 by 1.2 meters and contains 1,440 kg of water. Calculate the weight of the water. What is the weight of the water here?
It's 1440 into 10.
1440 into 10, which should be equal to 14400 unit.
Newtons.
Newtons. Okay. The pressure exerted by the water on the base of the tank. Pressure.
Well, first we need to find the area.
Okay. So find the area. What is the
So
area?
it's 1.5 into 1.2.
1.5 into 1.2. What is this value? I would rather do it like this. 1.5, 1.2 ones are 1.25 0.5s are. I will add these two. You'll get the answer as 1.8 unit.
Meter square.
Meter square. Okay. So I got the area here, and then what is the next thing?
The force exerted. So it's the force by surface area. So
What is the force?
14400
14400 divided by 1.8.
1.8.
Can you tell me what is the answer here?
8,000.
8,000. Unit?
Pascals.
Pascals, or maybe you can also write this as 8,000 Newton per meter square. Okay, you can write it in either way.
Yeah.
Then, but all the calculations has to be shown. Then figure shows two water tanks P and Q. P and Q, both the tanks are circular from viewed from above. The tanks each contain same volume of water. Depth of water in both the tanks is 1.4 meters. Same height. The density of water is 1000 kg per meter cube. Okay, density is given, height is given. Pressures exerted by the water on the base of the two tanks are equal. Calculate this pressure. At the base of the tank, he says that the pressures are equal. What is the pressure? How do we calculate? Pressure is always calculated as force by area. But here, if you want to calculate force, you should have the value of mg. Is the m given here? M is not given here. Then,
It's
which other formula would be useful? Only the depth is given. Is depth given? Yeah, depth is given.
yeah, the depth is.
Yeah, you calculate mass and then find out, or what is the other alternate approach?
We can't calculate the mass because we don't know the volume.
Yeah, so we do not know the volume, nor the area is given to you, right? Area is also different. So it's a smaller base here, is a larger base over here. So you will not be able to do using this formula. Then what do we do here? But there's a clue given here saying that same volume, right? So what we will do is we will just say, how do you get the volume here? If A is the area of cross section here, say I should have had something like this here. I should have had something like this over here. Okay. So therefore, or maybe it's a circular cross section, right? So it should be like this. It should be like this over here. It should be like this over here. It should be like this over here. Okay, like a funnel. Now, if I want, see, this is volume is same, which has been given over here. If I multiply this area multiplied by the height, what is that I get? Sorry, if I multiply this area, yeah. So I get the volume. Can we say that?
Yeah.
There is another expression, hope you know about this, which is rho GH. Are you aware of this equation?
Yeah, I think so.
Right. Okay. How do you get this? If you're not aware of this, let me teach you how do you get this. So what we do is I have this pressure equal to mg by a. I'll multiply on both the sides by L here. Okay. When I do this, I get the answer as mgl divided by a into L. What is a into L? Volume. Right?
Yeah.
I can now write this as mgl divided by volume. And then I will separate, or I will join this m by v. What is m by v tell you? Mass by volume gives you density, gravity, and this L is nothing but the height that I have used here. It could be this height, So you get this expression once again, right?
Yeah.
And when I do this, I need density, I need gravity, which I already know, and the height. So don't I get the pressure?
Yeah.
Okay, so now calculate the pressure here. So your pressure now will now be equal to 1000 multiplied by 10 multiplied by 1.4. What is the answer?
14,000.
14,000 pascals. Okay, fine.
Yeah.
So which means the same pressure is seen at both the places, right?
Yeah.
Okay, so always remember when you are inside water, the pressure only depends upon the depth from the surface. Okay, it does not depend upon what mass of water is above you. Is this clear?
Yeah.
Okay. So equal small volumes of water are removed from each tank. So I take up a mug of water from here. State which tank P or Q now has the greater water pressure on its base. Explain your answer. I'll remove 1 mug of water from here, or maybe 1 liter of water. Let me say, I'll remove 1 liter of water from here. And after removing, will the pressure gets altered or will the pressure be the same? What can happen? Which one will have less pressure? Which one will have more pressure? If I remove 1 liter of water, if I remove 1 liter of water, which means here the decrease in the height of the water level could be only so much. This could be your decrease in water level. Am I right?
Yeah.
So let me call this area A1. Let me call this the decrease in the water level because I removed so much. So not so much. Okay, I removed 1 liter of water. The water level dips down or drops down to this one. Let me call this as H1. Now, when I remove the same 1 liter of water, because this area is much larger than this one, so what can happen? This will be much, much lesser.
Yeah.
You will have one more height H2 here. Now tell me whether H1 or H2, which one will be larger?
H2.
H2 will it be larger? See, this has a larger area of cross section,
Oh,
right?
yeah.
So what we need to do
So
is we need to write A1 into H1 is equal to A2 into H2. Am I right?
yeah.
This is for the first container P and this for second container Q. This is for P and this is for Q. So I can now write the decrease in the level H2 is now equal to A1 by A2 into H1, right?
Yeah.
Now which is greater? A1 is greater or A2 is greater? If you look at from the figure,
A2.
A2 is greater, which means denominator is greater, and hence A1, so A1 by A2 becomes smaller. In other words, can you say that H2 becomes lesser than H1?
Yeah.
Okay, H2 becomes, are you getting me?
Yeah.
H2 becomes lesser than H1. Okay, when H2 becomes lesser than H1, so what else can happen? Now let us look at its effect on the pressure. We know that the pressure is equal to rho g H2 in the second case. Okay, what is he asking here?
Yeah.
Equal volumes of water are removed. State which tank P or Q now has a greater pressure. And now it's not H2, it is H over here. P equal to rho g H, where H is this height now. H is this height now. Am I right?
Yeah.
It is not 1.4, it is lesser than that. Now H2 becomes lesser than H1. That means this capital H, let me call this as capital H. Let me call this capital H2 here. This is called as capital H2 here. And let me call this as capital H1 here. Can you relate H1 and H2? The capital one, capital H1 and capital H2?
H2 will be greater than H1.
Greater than H1. As a result of it, can we say that P2 will be greater than P1?
Yeah.
Right? So therefore, your answer is, which one will have a larger pressure?
This
The Q
Q.
will have a larger pressure as compared to P. When you displace or when you remove equal volumes of water from here. Is this clear?
Yeah.
Then now let us move on to the next one. Figure shows a uniform rectangular slab of concrete ABCD standing upright on the ground. So you're having a slab here. The slab height has 1.6 meters. Mass is given, width is given. A force of 40 Newton acts horizontally to the left at B. So you are pushing this slab by some force. Calculate the weight of the concrete slab. What is the weight?
It's 18 into 10.
18 into 10. What is 18 here?
Yeah.
Mass here. Good.
Yeah.
Should be 18 into 10. Unit?
Newtons.
Newton. Okay. The thickness of the slab is 0.04 meters. So he has given you this thickness means I will extend this a little bit like this, backwards. Okay, so this is my slab now. This is my slab here. And yeah, so calculate the pressure exerted by the slab on the ground. So this value is already given to you. It is 0.040 meters. Yeah. So what is the pressure?
The force by the surface area of the base.
So what is this value? What is the force?
Force is 180 newtons.
Okay, divided by area.
It's 0.3 into 0.04 meters.
0.3 multiplied by 0.04 meters square. So what is the answer?
15,000 pascals.
15,000 pascals. Okay. Then B. On 2.1, draw and label an arrow to show the weight W of the slab acting at its center of mass. So how do I do? Where should I draw here? On the slab. Where is my center of mass acting? Where is my center of mass acting here?
It's acting in the center of the block, which
Of the block. Okay.
Yeah.
Which means it is here at this point. It's at this point.
Yeah.
Right? So it is acting here. So it should indicate it by this way. And while you indicate it, because the measurements are already given to you, you should clearly mention what is this distance. Okay, let me call this point as G. And this distance should now be equal to how much?
0.3 meters.
0.30 meters. 0.30. Two significant figures here. And then here, I should also mention what should the distance be from point D?
0.15.
0.15 meters. Okay, this should be very clear. Okay, so this is where it actually measures. And what is the distance here?
0.020 or
0.020 meters. You have to mention this clearly. All the three directions you have to mention. And here you can mention. Okay, so the diagram is drawn. The point of center of mass is at a distance of 0.3 meters, 0.30 meters from the base. Okay, and at a distance of 0.15 meter from the point D. You can mention at least two coordinates. Is this clear? Okay, though this could be only for 1 mark, but if the moment you start writing your paper more clearly, more legibly, okay, what will happen is the examiner will have an impression. Okay, the moment I read first 1 or 2 questions, even if you make a mistake, it will just go overhead. So I will not be able to notice that as an examiner. Okay, so you should try to write it in that manner. Then calculate the moment of force 40 Newton above the point D. What is the moment of force about the point D here? What is the moment of the force? That should be force multiplied by distance, right?
Yeah.
What is he asking? Moment of the 40 Newton force about the point D.
So it's 40 into
40 into 40 into which one? What distance? Is it 0.30, 0.040, 0.60? Which one?
it's 0.30.
No, it is not 0.30. It is a point of application of the force to the point D over here. That means that this is at a distance, a perpendicular distance here is seen to be 0.6 meters. Is this clear?
Okay, yeah.
So this is the place where the force is acting here. So this force multiplied by this displacement, you should consider. So this should be 0.60 meters. What is the answer for this?
24
24 unit
Newton meters.
Newton meters. 24 Newton meters. Okay. The moment of W about point D. This is your W, the weight. I should not call this as G. G stands for centroid. I can call this as W. Yeah. Now, what is the moment of W about the point D?
But you would have to find the distance. So wait.
What is the distance?
It's around 0.3. 0.3.
No, this is 0.15 because weight is acting at the center here, right? Along this plane, along this line you should take, which is 0.15. So 0.15 is your distance. And weight, what is the weight? Weight of the slab?
The weight is 180 newtons.
180, yeah. So the answer should now be
27
unit
Newton meters.
Newton meters. Okay. The ground is so rough so that the slab does not slide. Okay. The ground is so rough because it does not slide. State and explain what happens to the slab as the horizontal force at B is gradually increased. Now what is happening is this is the ground and now I have applied a force here. This is not going to slide here. It's very rough. Okay, so now when I increase this force from 40 Newton to 50, 60, 70, 80, and so on, what can happen to the slab? Will it slide? First question I should ask now is that
at B.
Yeah, continue. Then we'll see. Yeah.
It'll and it won't slide, but it'll rotate.
It will rotate. Why doesn't it slide and why should it rotate?
Because
Okay, now let me explain this. If you had applied the same force over here, will it slide? At the center of mass, if I had applied, will it slide?
Yeah.
Why should it slide? Why not rotate there also?
I'm not entirely sure.
Okay, so now let me ask the question, when does an object rotate? When does an object rotate? Under what conditions can an object rotate? When does an object rotate? The basic question.
When a force is applied in a certain direction and there's a wait, like,
okay, let me tell you once again. When I talk about rotate, that means there is a torque. Agreed?
yeah.
There is a torque, or you can also say that there is a moment of force. Only when there is a moment of force, the object will not rotate. Am I right?
Yeah.
Okay. Now towards it, now it depends upon where is your axis you are considering. For example, when I make the same 40 Newton appear here and you push this here, now if I ask you about the point D, what happens? Then definitely this force multiplied by this distance now becomes reduced, which is 0.3 meter. And as a result of it, okay, if you apply larger force, this may again topple down like this.
Yeah.
It will rotate. So now if I apply a force here, let us say I am applying a force somewhere over here. The distance between this point and the ground is not 0. It is something like around 0.15 meters. Will it rotate? If I apply a force here, the same 40 newtons, or maybe I'll make 400 newtons, will it topple or not?
No.
Why?
Wait.
Does it have a torque? See, this force,
Okay.
point of application of the force is at a distance of 0.15 meter. Will it have a torque? Will it have a moment?
Yeah.
Okay, whenever the moment, if the moment is not equal to 0, the object will rotate. Remember this.
Yeah.
Okay. The only place where the object cannot rotate is when you apply it here along this line. When you apply a force here, the object will be moving like this. It will not rotate. About the point D, I'm talking about. But about the center of mass, if you ask, definitely it can rotate. So that's a different story. So now about the center, about the point D, it will now just slide across. Is this clear?
Yeah. Yeah.
Okay. Okay. So now we have seen when does an object rotate, when does the object does not rotate, and all this here. Now what is that he is asking? The ground is rough, the slab does not slide. So if something has to rotate, there should be two forces that are equal and opposite. Opposite, separated by a distance. Separated by a distance. So only then an object can rotate. Now, as a result of this, now there's one force which is acting in this direction, which is a frictional force when you try to push it across. And there's one more force, which is the actual force. Okay, if the distance between these two forces is equal to 0, or which means if both the forces are acting along the same direction or in the opposite direction, or the distance between them is 0, in that case, the object will not rotate. Now you see here, Staten explains what happens to the slab as the horizontal force at B is gradually increase. When you gradually starts increasing this force is larger, and at the same time, the static frictional force will also increase, right?
Yeah.
And after a beyond moment, some moment, what happens is the static frictional force remains a dynamic frictional force, and this will have some value. So you will have some value here, you already have some value here, and the distance between them is already existing, and hence the object will now start toppling down, and hence it will not slide. Is this clear?
Yeah.
Can you repeat?
Well, so when the force is increased, the distance it remains the same, but the moment of force will increase, which wait.
Yeah.
Yeah. So when the moment of force increases, it causes the torque to increase, so the object will rotate and it'll topple.
It will fall down, it will topple down to the ground. Okay, good. Okay, let us move on to the next one. A large crane has a mass of 8,500 kg. Figure 4.1 shows the crane on a muddy building site. Okay, standing here. Calculate the weight of the crane. Very simple question. Yeah. What is the weight?
8,500 into 10, so it's 85,000
85,000 unit
newtons.
newtons. The crane rests on two caterpillar tracks, each of which has a contact area and a ground of 3.4 square meter. Okay. So area is given for these caterpillar tracks. These are called as caterpillar tracks. The large wheels that you have here. Here. Calculate the pressure that the crane exerts on the ground. What is the pressure?
Um, 85,000 by 3.4 meters square.
85,000 by 3.4 meter square. This is the pressure exerted on only one track. Only one track. Then you will have two tracks there, right?
Okay, yeah. So
So they
it's
should be
into
multiplied by 2.
2.
Okay. So this will be 2 into 85,000 divided by 3.4. What is the answer?
Wait, so shouldn't it be 3.4 into 2? So
See the total pressure. This is the object. The total pressure P is now divided by two pillars. Here and here.
yeah.
This should be 2 into 3.4. Not, this is not the way. You're right.
Yeah.
85,000 by 2 into 3.4. Yeah. As the area increases, definitely the pressure at every point will decrease. Yes. Now tell me what's the answer?
12,500
Unit?
pascals.
Pascals. As the crane driver walks towards the crane, he starts to sink into the mud. He lays a wide plank of wood onto the mud when he walks along the plane. Explain plank. Explain why he does not sink into the mud when he walks along the plank. What is the reason?
Because the plank has a larger surface area.
The plank has
So
a
the
larger surface
pressure,
area. Yeah.
so the pressure that's exerted onto the mud will be less because of the larger surface area.
Yeah. So larger surface area, pressure now reduces. Okay. When the crane lifts a heavy load with its hook, the load exerts a moment on the lifting arm of the about the axle. Explain what is meant by the moment of a force.
It's the rotating force, the torque.
Yeah, the torque. Can you just say it's a rotating force of the torque? You should exaggerate this a little bit also. It is calculated by the force applied multiplied with the distance between.
Distance
Distance between
the
center
between
of
the point.
mass, or maybe the point under consideration.
Yeah.
Okay. Then, despite the moment exerted on lifting arm, the crane remains in equilibrium. State the two conditions required for any object to be in equilibrium. See, you put an object over here, and as a result of it, the force is acting here. You should expect that the crane should topple down, but that's not happening. But why does the crane remain in equilibrium? And explain the conditions required for any object to be in equilibrium.
The opposite forces acting on the object should be equal.
Opposite forces should be equal. Okay.
And the torque in opposite directions should also be equal. Yeah.
Torque should be balanced. Okay, or you can also say the anti-clockwise moment should be equal to clockwise moment. Clockwise moment, and only then the object will not topple. Right.
Yeah.
Figure shows a mobile bird sculpture that has been created by an artist. M is the center of mass of the sculpture, including its tail, everything, but not including the counterweight that will be added later. Okay. The mass of the bird and the tail is 1.5 kgs. Okay. The bird sculpture is placed on a pivot. So this is my pivot here. The artist adds a counterweight at the end E of the tail, so the bird remains stationary. Counterweight at end E, because this side, because this weight is much larger, it can fall down here because the entire mass is here. So he adds one more weight here. He puts a big weight here. Calculate the mass of the counterweight. What weight should he add so that it doesn't fall down? What should be its weight so that it doesn't fall down? Mass of the bird is 1.5 kg. So here it is 1.5.
So the weight is so the weight is 15 newtons, and the distance is 12 centimeters. So it'll be 15 into 0.12.
So
that's the moment.
So the moment which is acting in this direction here, which is your anti-clockwise moment. So if this is not being disturbed, anti-clockwise moment should now be equal to 15 Newton multiplied by 0.12. And the clockwise moment should be? They should be equal to it, right? Yeah. What should be clockwise moment?
So 0.3 into the weight.
Let me call this as W. W into 0.3. Now equate these two. 15 into 0.12 is equal to W multiplied by 0.3. So how much will this be? It will be 15 into 0.04 is equal to W.
Yeah.
0.3, right? So 3 fours are, you'll just use 0.4 here. So 15 into 4 is 6. 6 should be your W. What is the weight? The weight is 6 Newton here. Now you need to find the mass here. Remember, he is asking you the mass. So the mass here should be
0.6 kg.
0.6
or 600 grams.
600 grams. The center of mass of the sculpture with the counterweight is as a pivot. Calculate the upward force acting on the pivot. Center of mass of the sculpture with the counterweight is the pivot, which means that I have taken this, put it over here. So this is my pivot now. I take this and I also drop it over here. Now what is the upward force acting at the pivot? Did you understand the question?
Yeah.
Okay.
But shouldn't the it says that the center of mass of the sculpture with the counterweight is at the pivot. So
exactly.
So shouldn't the center of mass be in the center at the pivot instead of the other way around?
See, you cannot move your center of mass here. Okay. Center of mass depends upon the geometry of the object, which will remain as such. Whether you keep the pivot here or you keep it here, wherever it is, with the weight, without weight, the center of mass remains the same because you are not moving any mass. Center of mass depends upon the arrangement of the mass. So as a result of it, it remains here itself. So what I do instead is that I take this point and pivot it over here. And then I remove this mass and I also add it over here. Now I ask, what is the total upward force acting on the pivot? Which should be?
Well, it would have to be equal to the mass acting downwards.
Exactly. Which should be 15 plus 6,
Well, wait,
which is 21 Newton.
force. Yeah.
Okay. Then the sculpture is rotated clockwise to the position shown in the figure. Now pivot is over here. It is held still and then carefully released. State whether the sculpture will stay in that position or rotate further clockwise or rotate back anti-clockwise. What can happen? He has added the required weight. Okay. The weight which was used to balance this one earlier. And then what he has done is he has rotated this by a little bit like this. Initially, it was like this. Now it has got rotated like this over here. Now, as a result of rotation, the moment I leave it, will it again remain the same position or will it again come back to the original position? Or will it rotate in the clockwise direction? Which one can happen?
It'll come back.
Will it come back? Why should it come back? So you mean to say that this bird, it will now rotate like this and again restore to its original position?
Yeah.
Oh yeah, okay, you're right. But why should it come back?
Because when the counterweight is okay, wait. Yeah, when the counterweight is pushed down, then there's an extra force being added there. So the moment of force increases, but when you release it, that extra force is gone. So the moment of force will go back to what it was before.
In that case, do you mean to say that when I release it, this mass becomes more larger? Or the point of force here becomes
No,
larger?
no.
Then?
Well, the moment of force of the counterweight will decrease.
So what happens is when it was at this position, and it was in a horizontal position, this counterweight was somewhere located here, correct?
Yeah.
Which means the distance here was much larger. Distance here was much larger. Let me call this as R over here. And this distance, let us say, for example, it is R1. Let us say this is R2 over here. And we can say that R2 is lesser than R1 here. When R2 is lesser than R1 and F, what is F here? F is nothing but the weight, the counterweight. Okay, so F into R2 should be less than F into R1, right? Which means the moment that is acting downwards is much lesser as compared to here. And as a result of it, this becomes lesser. Now, let us analyze the same thing here also. Here, let me call this as X1, or maybe the new position. This is your new position. This is your X2, and this was your X1 over here. This was your X1. Now, here you had mg multiplied by x1. See, x1 was okay. Let us write down like this. x2 is less than x1, or mg multiplied by x2 is less than mg multiplied by x1. Okay, so therefore, if it is in such a way that if these two moments are unequal, mg x1 and f r1 are unequal, in that case, what can happen is, okay, it will go in the required direction. So here the statement is not very clear. State whether sculpture will stay in position, rotate further clockwise or rotate back anti-clockwise is not very clear, because the value of x1 and r1 should be known to me. Only then I will be able to comment on it. Now what I can do is I can now say that if mg x2, if mg x2 is lesser than, what is mg x2? The moment at this point with respect to this, mg x2 is lesser than f times r2. If mgx2 is less than fr2, then it will move in a clockwise direction. If mgx2 is equal to fr2, it will remain there itself. It will remain there itself. While if mgx2 is greater than fr2, it will move in an anti-clockwise direction. Is this clear?
Yeah.
Okay, so it should be analyzed depending upon what is the kind of questions that has been asked. If the mass is really very, very high as compared to this, okay. So for example, what was the mass in the earlier case here? Here it was seen to be 1500 or 1.5 kg here. And what was the mass added over here? The mass added was 600 grams. So it's nearly double on that. As a result of it, you can't expect much of changes, and hence your answer would have been right. Okay, that means this mass is really larger, and hence MgX2 is much larger than this, and hence it will again come back to its original position. Or it will restore back it will move in an anti-clockwise direction. So the answer should have been anti-clockwise. Did you understand? I have taken a generalized solution, and then I have come to a specific solution. Is this clear?
Yeah.
Okay. Then state what is meant by center of mass.
It's the point.
Yeah.
It's the point where so all of the mass of the object is concentrated.
It's the point where the entire mass of the object is concentrated. Okay. Point where entire mass is concentrated or focused. Shows an athlete successfully presenting a high jump. The height of the bar above the ground is 0.2 meters. So this is the ground is 0.2 meters. The maximum increase in gravitational potential energy of the athlete during the jump is calculated using the expression GP is equal to mgh. Okay. Then explain why the value of h is used in the calculation much lesser than 2 meters. Height of the ground. So he has taken this one. Yeah. Explain why the value of h used in the calculation is much lesser than 2 meters. What is the reason?
Wait.
The figure itself tells you the reason behind it.
It's because he's jumping from a higher platform.
Yes, he is jumping from a given platform, and as a result of it, okay, the height that you use here is different. Okay, so you need to consider this height. You need to consider this height here. Is this clear?
Yeah.
Figure shows in order 5 stages of an athlete performing a pole vault. Okay, describe the energy changes that takes place during the performance of the pole vault from the original stationary position of the pole vaulter before and up to the final stationary position after the vault. So what are the energy changes that takes place? So you start from here, then you run, then keep your pole here, then you jump and land onto the bed here. So what are the energy changes that take place? While you run here, you are increasing your velocity. Am I right?
Yeah.
So when you land over here, when you just stop here, just before lifting up yourself, your total energy was, because you are now to talk about the energy changes here. So here I talk about the initial kinetic energy, right?
Yeah.
This should be half mv square. Then after that, you apply that half mv square and keep your pole, and then you jump across. Now, as a result of it, what is that? How are you converting this energy to go to a height?
It converts to potential energy.
No, you're not directly converting it to potential energy. You are converting this to the elastic energy. Elastic energy of the pole. After this, what you do? This again gets converted to increase in potential energy. Increase in potential energy. Then you jump the vault, and after that, you fall down. And when you fall down, potential energy reduces to 0. Is this clear?
Yeah.
Okay. Fine then. So today we will stop here. Next class we'll continue with the next chapters. Okay.
Yeah.
Yeah.
Okay.
Fine. Bye.
Bye. Thank you.